Hey, everybody. Welcome to your lesson for 324. I am your host, Miss Hovdit, and tonight's top story is people aren't doing their homework. Okay, 324. How does this work with decimals? So here's your warm-up. Represent each of the following decimals on the hundredths grid. Use your resource page on your table. Okay, so there were little pages on your table, or there are if we are in school. If there's not, it's okay. I do not want you to draw a hundredths grid if you don't have one, so just kind of watch. But if you are in school, then pause the video for about 1 minute, shade these in, and then play the video. Okay, so here is what I would have done. 0.6, you can go in either direction, doesn't matter, but each of these are 10 or tenths. So one row is 10, and we need 6 of them. So 1, 2, 3, 4, 5, 6, because it's 6 tenths, right? And each row is 10 of them. Total hundredths grid, but it's one row is a tenth. So 6 of them. 0.25 or 25 hundredths. That means we need to shade 25 of them. So since there are 10 in a row, you got 10, 20, and then 1, 2, 3, 4, 5. Okay, here you go. Homework answers. If you would like, you can pause the video and look at these. I'm going to keep going. Today, 324, students will review multiplication of decimals, numbers using hundredths grid, generic rectangles, and fraction equivalencies, and use their work to make sense of the standard algorithm for decimal numbers. So, how does this work with decimals? Just like decade is another name for 10 years, a decimal number is a number that can be written as a fraction whose denominator is a power of 10, which is like 10, 100, 1,000, etc. Things that can be multiplied by 10 and divided by 10, power of 10. Something times 10. Because our entire number system is based on 10, decimals are very important. They're everywhere. Much of the math you see in science class uses decimals as well. Of course, you also use them whenever you work with money. Today, you're going to practice working with decimals using what you know about fractions to make sense of the standard algorithm for multiplying decimals. As you work with your team, keep these questions in mind. How are these decimals like fractions? What does place value have to do with our answer? And does our answer make sense? We always are saying that, right? I always say that. Does your answer make sense? Don't just say yes. Actually see if it makes sense. All right, 64. Our good old friend Howard went to the mall and saw a banner announcing all sporting goods 1/10 off. No store does that, but this is math, so we're going to go. He saw a pair of rollerblades laces for 40 cents. What a steal. And wanted to find out how much he would save, because don't we all? With your team, follow the steps below to help Howard determine his savings. So it says get a copy of the resource page. Should already be on your table. That's that hundredths grid I was chatting at you about. It says, or you can use this e-tool. So there you go. If you're at home, use the e-tool. It contains several copies of the hundredths grid, which you will be using throughout this lesson. Hundredths grids are larger versions of unit tiles. Each side measures 1 unit divided into 10 equal parts. Okay. So we're continuing. Number 64 says, what is the perimeter of each hundredths grid and what is the area? Okay. Well, if we're going to split it into tenths, okay, this is each 10 parts, but total, the whole thing is a whole, right? So I actually don't remember what the answer is. So I don't remember if it split it into 10 or if it didn't. And so I am going to go look. And you guys are going to join this journey with me because I'm not pausing the video. So otherwise, I have to start all over again. And I was funny the first time, so I don't want to try again. Okay. Now, if it is 1, if we do want to go 1 by 1, then the perimeter all the way around is very good. It is 4 because every single one is 1 and there are 4 sides. So 1, 1, 1, 1 would be 4. If we're counting the tenths, then the perimeter would be 10 by 10 by 10 by 10, which would be very good, 40. I feel like I'm Dora right now. Maybe I should wait a little bit longer. She's better at it than I am. So that's what that would be. Now, if we're talking area, if we have a 1 by 1, an area of a rectangle is base times height. So 1 times 1 is very good. 1. Did I do better? And if it was 10 by 10, then the area would be You got it, 100. So we're still getting there, as you can see. And let's go. Chapter 3, 3 to 4. I get all of the answers because I'm a teacher. If you want the answers, go to college for 4 years and get your teaching degree. 64 is what we were on. Okay, here we go. Here we go. Just gives me units and square unit. There we go, 4. Okay, so it is saying it's a 1 by 1. Okay, so that's the first one that we wanted to do. So we want to stick with that answer, 1 by 1. So our perimeter is 4 and units, and our area is 1 square unit or 1 unit squared. Either way, totally fine, but it's a square unit. Okay, I'm glad we went on that together. So the next one says, what do each of the small squares of the grid represent? Write your answer in 3 forms. So we just talked about that. They're all split into little tiny pieces. There's a total of 100. So one of them would be 1 out of 100. Okay. Pause the video and figure out what the decimal and percent equivalencies would be for that fraction. So go for it. 30 seconds. And we're back. 1 divided by 100 is 0.01, and as a percent, it is 1%. Okay? Why do you think they're called hundredths grids? I think I kind of explained that already. There's 100. It's broken up into 100 pieces. They're all 1/100th, so 100th grid. D says 40 cents of the cost of Howard's laces, which is the cost of Howard's laces, can also be written as 0.40 or simply 0.4. On your resource page of hundredths grids, lightly shade and label 0.4 or 4/10 vertically, as shown in the diagram at right. Vertically is up and down. So just like this one. So take a second, pause the video. Everybody shade in 4/10 of the grid. Okay, here we go. Next, in the other direction, because it's 1/10 off, remember 1/10 off, you're going to shade 1/10 in the other direction horizontally. Okay, just like it shows right here. And then make sure you're labeling those. So 4/10 on the bottom, 1/10 on the side, because you want to show 4/10 was this way, 1/10 was this way. Okay. And now we need to figure out what is the decimal equivalent of the part of the grid that is darkly shaded. That means this part right here that got shaded twice when we shaded this way, and what got shaded twice. So pause the video, 2 minutes, work on questions F and G with your team. So pause that video. And we're back. So write the 2 equations that represent the process, one using fractions, one using decimals. Well, 4 out of the whole thing is shaded double, so fraction would be 4 out of 100, and then using decimals would be 0.04 because it's 4/100ths. 4 little squares, 4/100ths. So how much money will he save on those laces? He will save a whopping 4 cents, you guys. Wow. What a deal. Man, that's great. All right, next one. 65. While in the sporting goods store, Howard's finding some more deals. He found some new running shoes advertised to weigh only 70% as much as his old ones. Dang. His old shoes weighed 0.8 kilograms, and you're going to use the problems below to determine how much those new shoes weigh. Okay, so I'm going to have you just work with your team on this one. Okay, do questions A through D in 4 minutes. So pause the video, come back in 4 minutes. Okay, how'd that go? Hopefully good. It says use a hundredths grid to find 70% of 0.8 kilograms. So you're using that resource page that you got to do that. It says write a fraction equation for this problem. Well, we have 70%, which is 70 out of 100. And then it says of, and we've talked about that before. Of means multiply. So we multiply, and then 0.8 would be 8/10. Okay, so that's our fraction. A decimal equivalent would be 0.7. You could do 70, that's fine, times 0.8. Okay, and then it says, do the new shoes weigh more or less than the old shoes? Again, asking yourself, does it make sense? He found shoes that weigh 70% as much. Okay, so they don't weigh 70% more, they weigh 70% as much. So it should be that they weigh less. So you should end up finding out how much they weigh, and then you're going to have to subtract. So if you didn't do that last step, make sure you do that last one. So here's what I did. I did 0.8 going in the one direction, 70% going in the other direction. I had 56 of the hundredths double shaded. which means 56 kilograms, is how much the new shoes weigh. But to find out how much less they were, I have to take 0.8 minus 0.56 because they were 0.8 kilograms. Now they're 0.56 kilograms. So how much do they weigh? That you get 0.24 kilograms less. So they weigh 0.56 kilograms, but they are 0.24 kilograms less than the new shoes, the old shoes, excuse me. Okay. 66 says another way to think about decimal multiplication is with a generic rectangle. Not often am I going to ask you to multiply decimals without a calculator. This is just so you can understand the process in case for some reason you would need to. Okay. What multiplication problem is represented by the generic rectangle shown below? On your paper, copy this rectangle and write the multiplication problem it represents. So while you are drawing this on your paper, go ahead, go for it. Let's look at it. So just like any other generic rectangle, we have one number on the top and one number on the side. And we broke it up in two parts so it makes it a little bit easier to do. And so to say the problem, we just have to put them together. So 2 plus 0.3 is going to be 2.3. I'm really hoping you're saying these out loud and not everyone's just being uncomfortably quiet. So 2.3 times, and then 1 plus 0.4 is 1.4. So that's the problem that this represents. We split it up, okay? We have to fill in the 4 sections. So this first section here is 2 times 1, which is 2. This section here is 1 times 0.3, which is 0.3. This section here is 2 times 0.4, so 0.4 2 times, which would be 0.8. And then this last one, we've talked about this before. 0.4 times 0.3. To do that quick math in your head, you do 3 times 4, which is 12, and then we have 2 decimals, so move it back 2, and we got 0.12. Then we got to add them all up. So we have to do 2 plus 0.3 plus 0.8 plus 0.12, and let's see, that's 1.1, 3.1, 3.22. Okay. So as a sum would be this right here. It says write the total area as a sum. That's this because a sum is adding things together. And then as a product, we would just write 2.3 times 1.4 equals 3.22. It's the same thing, but it's just writing it 2 different ways. And then the next part says use the standard paper and pencil method. I don't really know why it's called that. I've referred to it before. This is paper and pencil method. I've referred to it before as the stack because you're just stacking it. I don't think that's real, but if it's not, I should coin the term and get some money for it, right? This is stacking, okay? I'm not going to go through problem 67. If you would like, you can, but just if you need to, read through that, and you can do that, okay? Like I said, I'm really not going to ask you to multiply decimals by hand very often, if ever. So if we're good with the generic rectangle, we'll stick with that for now. If you like this way and this way makes sense to you, please keep using it, okay? I'm just not going to take the time with this video to go through it. Or if you want to know, ask me and I will do it, okay? Here is math notes today. So if you need help with multiplication of integers, please look at this. And your closure today, Howard, our man Howard, he is in his new lightweight running shoes, okay? He was able to walk at a rate of 0.83 meters per second. His coach timed his walking at a steady pace for 12.2 seconds. I don't know what sport you're doing where you're just walking and your coach is timing you, but hey, sign me up. How far did he walk during that time? Use a paper and pencil to show your work and check your answer with the calculator. So I set up the generic rectangle. Do this. Give about 3-4 minutes, depending on how much time you have left in class. Do this, come back for the answer, check your work, okay? 4 minutes, pause the video. All right, Howard, let's see how fast our dude walked here. There's all my work, added them together. I got 10.126 meters. Hopefully you did too. All right, today's homework is 73, you can skip 74, and then 75 through 77. So work on that. I will check this homework when I get back, or maybe the sub will check it. I'm not really sure, but do it because it's important, right? And I'll see you guys soon. See you later. Bye-bye.